In this video, we will cover how to create a simple plot in Matlab. It is assumed that you already have an understanding of discretization and the fundamental concepts of programming in Matlab, such as variable assignment and scripts. We begin by first creating a new script, which is done by clicking on the New Script button in the upper left-hand corner. Notice how, once clicked, there is a new box entitled Editor above the command window. This is where we'll be rewriting code for our basic plotting script. Following good programming practice, it is always good to start off with a comment to inform whoever will be reading your code what it does. Let's start by creating a comment saying, "This is a script to create a basic plot in Matlab." Now remember that any text that follows a % is a comment and is not read by a computer. The first thing we want to do in plotting is to define a grid of values that will correspond to the independent variable. This is done by specifying a minimum value, a maximum value, and the spacing between each grid point. Remember, as the spacing increases, the number of points will decrease. So let's begin by now specifying our minimum value, xmin, and let's specify this as -2. Let's specify the maximum value we want x to take on as +2, and the grid spacing as dx, and let's call the grid spacing 0.1. Now notice yellow equal signs have appeared. This is to tell us that Matlab will automatically output the value once the script is run. However, this will slow down computation time. We can alleviate this by placing a semicolon following each variable assignment. What the semicolon does is tells the computer to know that variable and store it, but do not display it to the screen. And this will allow your code to speed up. Now what we do is we have to specify the grid of values. This can be done by using the colon operator. In essence, we want to create a command that will tell the computer to create a set of numbers starting at the minimum value, -2, going up by 0.1 or the grid spacing, and ending at +2. And this can be done by using the colon operator. Again, remember we want to put a semicolon after each variable or command so that it's not outputted to the screen. So we can do this by specifying our grid as xgrid is equal to xmin, moving up by dx and ending at xmax. Again, it will be useful to specify a comment telling what this command does. So let's define this as our grid points. Now that we have the independent variable, we want to find a way to create our dependent variable, y is equal to x squared. So again, starting with a new comment, we want to create the variable y such that it takes in every element of x and squares it. Now in Matlab, we have to specifically tell it to take each element in the set of numbers and perform an operation on that element. Because Matlab assumes that you're going to be dealing with arrays or vectors or matrix multiplication, and we want to explicitly state that we do not want to multiply matrices. Rather, take each element within an array and perform an operation. This can be done by using the period operator. So to define our y value, we can say that y is equal to the value of xgrid dot, again, this dot is telling us to take every single value within that xgrid array and do something to it. And what we'll do is square it. And therefore, we have created our output variable y. Now that we have the independent and dependent variables, we want to plot them. We can begin by initializing the figure using the figure command. So again, with a comment, let's say initialize figure, and we do this with the figure command. Now I should mention that this is not required, but it'll be useful when we discuss more advanced plotting in later videos. In order to plot the data, we'll use the plot command, given by plot. This command can take a variety of arguments in order to customize the plotting style, such as color, line width, shading. But for now, we will deal with the inputs of the independent variable, dependent variable, and color. This function plot will create a line plot in which each point is connected by a line and the individual points are not shown. Now notice that if I just start writing the plot command, it will give me some information about some of the arguments it'll take. So we see that the first command is the most basic, which says take two variables and assign them as the x and y values. So let's begin by doing that. So our x values will be given by xgrid. Our y values are given by y. And we can specify the color by inputting the string. Again, remember, strings are given by values inside quotation marks as blue. So here we have our basic plotting command. Now before we jump into actually plotting and running this script, let's realize that a good figure should have several attributes. These attributes are a proper window, which can be thought of as correctly specifying the x and y limits of the axis labels, and a title. We can use the commands xlim and ylim, which take in two numbers closed inside of square brackets that specify the minimum and maximum values respectively to specify the window size. Now these commands should always follow the main plot command. So here again, starting with good programming practice, let's create a comment that says specify figure attributes. So again, the xlim will take in two values enclosed in square brackets that specify the bounds. And let's say -5 and 5. Similarly, the ylim command will specify the windowed values for y. Now we're not quite done because we want to label these plots. This is done by using the x label, y label, and title commands. Each of these commands will take in a string that will be used as the label. So if we wanted to call our x-axis x, we'd say x label, parentheses, takes in the argument of the string that's going to be read as x. Similarly, the y label will be read as y, and if we want a title, let's say a simple plot, we use the title command and that will display a title for the plot. Now that we have this script finalized, we press the play button and it will run the script. Notice that we forgot to save the file. If we wanted to explicitly save it before running, we can click the Save button located in the upper left-hand corner. So let's save this file as simple plot, and it will save it as a Matlab file.m. Notice now we have an error, and this says that there is no variable entitled xmax. Now remember what I said earlier about the importance of specifying variables and carrying them through your entire program. So we go here and look at the line that says line 8 where the error is, and it says, uh-oh, I don't recognize this variable xmax. I don't know what to do with it. We can fix this by renaming it what we defined it earlier as xmaximum. Saving this, and now running it again, will create a plot. Now, one more thing that I want to notice is that I did not place a semicolon after this x maximum. And the result is the showing of every single value that x maximum or x grid will take. Now, for a simple plot like this is not very computationally expensive, and it doesn't really slow down the plotting procedure. However, for more intricate programs, we do not want to do this because it will take computing time in memory to display each one of these values. So let's exit out of our plot, put a semicolon in, and now run. And alas, we have our simple plot of a parabola with x label x, y label y, title simple plot. To save the plot, we can do File, Save As, and again, let's say simple plot. In the format, we can specify as a figure file, which is not all of that useful if we're coming up with a figure for papers, or a variety of different extensions. So let's save it as a JPEG. Click Save. And now we have successfully created a simple plot in Matlab. Thank you for watching, and I look forward to seeing you again in more future